Kia ora again. So we've gone through 4 of the sections of this task. We've gone through tool, trial, record, and part of the conclusion. So in this video we're going to finish off the conclusion and look at the discussion, which finishes off the task itself. So in our task, let's go back to the description actually, they asked in the conclusion to include an estimate of the average number of chickens checked and the chances of having 2 or more black chickens and any other findings from your simulation. So we've found the chances of having 2 or more black chickens, but we haven't yet looked at the average number of chickens checked. Now this means the average number of chickens checked. This means the number of chickens checked before you found 2 black chickens, because that's what we're looking for. If you find 2 black chickens, then you don't need to check the rest of the 5, because you've already found the 2. But if it takes you all 5 and you have to, and before you find your 2 black chickens, or you check all 5 and you still haven't found them, then you've checked 5 chickens in total. So we're going to go back to our Google Sheet and then work that out. So this is the sheet we had before. These are our successful trials, and in this column we're going to look at how many chickens we checked. Chickens checked before 2 black chickens were found. So if we look at that first trial, we had 5 chickens checked and we still didn't find 2 black chickens. So we checked all 5 chickens. In this second trial, you checked 1, 2, 3, 4, and at the 4th chicken you found your second black chicken. So 4 chickens were checked, and you didn't have to check the 5th one because you already found your 2 black chickens. Same with this one. You checked 1, 2, 3, 4 chickens, and then 2 black chickens were found. Excuse that sound, that was some pigeons outside. So that is number 4. 4th chicken that you found your second black chicken. In this one, only 1 black chicken was found, so all 5 were checked and you still didn't find 2 black chickens. In this one, after checking the first 2 were both black, so you only needed to check 2 chickens, and so on. So this one, the first 2 are black, so after 2 you could stop checking. This one, after the 3rd one, you found your second black chicken, so only 3 chickens needed to be checked. Same with this one. With this one you only found 1 black chicken, so that means you checked all 5. This one you checked all 5. This one checked 3. This one checked all 5. This one checked all 5, because you got your first one there, and then your second one was your 5th chicken. This one was the second chicken that you found was black, so you only needed to check 2. 2 again. 5 were checked and still didn't find all 2 black chickens. 5 were checked to find the second black chicken. You had 1 black, second black was chicken number 3. First black, second black was chicken number 5. First black, no other black chickens, so you had to check all 5. This one was 4, this one was 5, this one was 5, this one was 5 again because you didn't get all black chickens. The 2 black chickens, this one's 5, this one's 4, this one's 2, this one's 2, this one's 5, 5. Now you'll notice that the columns where you didn't have a successful trial, that's when you had to check all 5. So any of them that had an unsuccessful trial, you should have checked all of them, because you needed to get through all 5 black chickens and you still didn't find 2 black chickens. So that's that. So we've noted down in each trial how many chickens were checked before you found 5 black chickens, and now we're going to work out the average. So on average, if you checked the same number of chickens, if all of the black chickens were evenly spread out among all your trials, how many chickens would you check before you found 2 black chickens? So we're going to work that out. Average number of chickens checked before success. before 2 black chickens found. I'm going to move this. Oh, why did that go away? Average number of chickens checked before 2 black chickens were found. I'm going to take that and I'm going to move that over here. Oops. So you can see the whole thing. Let's see. Yeah. So I'm going to take the average of this column here. So equals average, and this is another formula you can use to make it go really quick. So I'm going to take the average of this column. So again, I go equals average bracket, and then I'm going to select all the cells I'm going to take the average of. So up to there, close bracket, enter, 4. So if all of the black chickens were evenly spread among all the trials, on average, you would need to check 4 chickens before you found 2 black chickens. That's your last calculation done. So go back here and we fill that in. So we go to our conclusion. So the average number of chickens checked to get 2 or more black chickens is the total chickens checked divided by 30, which is your average, and that's 4. And that answers my final question in the conclusion. The average number of chickens checked before 2 black chickens are found is 4. Now, if you get a decimal, you need to round up. So say you got, for example, if you got 3.6, you can't check 3.6 chickens. You can't have 60% of a chicken or 50% of a chicken. So you have to check a round number. So you'd have to round up because you didn't find all 2 black chickens at 3. You'd have to check 4 chickens. Okay, so if you get a decimal, you need to round up. And that's the conclusion part done. Now for the discussion, we're going to look at the assumptions we made and how that might affect the simulation and how that might affect our results and what we might do to improve our simulation. So the first assumption is that we're assuming that, so this is just something that I've come up with. These aren't all of the answers. These are just assumptions that I've thought of. If you think of different ones, write that down, see how that would affect your simulation, see how it would affect your results. So, and this is going to make our, some of these assumptions make our simulation, our investigation, less reliable or less valid. So we can't rely on the results, or they're not measuring the thing that we want to measure. So the first assumption that I thought of was we're assuming that there are still a similar proportion of black and not black chickens as in 2015. So it's 2021 this year when I made this video. So I don't know whether there's still 40% whether at the farm 40% of the chickens are still black, because that's what they said. They said the farm started in 2015 and they calculated that 40% of the chickens in that year were black. So we're using that to do our investigation, but we're doing it in the future. So those proportions might not be the same. So the effect on the simulation is that there may be different proportions of black to not black chickens, which would change the probability of seeing each one. If the breeders wanted black chickens, maybe they only used black chickens to breed, which would increase the likelihood of their offspring being black, and there would be more black chickens. If you're only breeding black chickens, you're going to have more black chickens. Similarly, if they didn't want black chickens, they would only use chickens that weren't black to breed, and this would decrease the likelihood of their offspring being black, and there would be fewer black chickens. So that's the effect on the simulation. The effect on our results is how that changes the probabilities and our averages. So if the percentage of black chickens from 2015 has changed, this makes the result of the simulation less reliable. If black chickens are used to breed, the actual probability of getting 2 black chickens of the 5 would be higher, and you would need to check fewer chickens before you would see 2 black ones. So if there are more black chickens, you're going to have a higher probability of seeing black chickens. You're going to need to check fewer chickens before you see 2 black ones. If the chickens that aren't black are used to breed, the actual probability of getting 2 black chickens of the 5 would be lower, and you would need to check more chickens before you would see 2 black ones. So that is what an investigation into an assumption might look like. So it's pointing out something that might make our investigation less reliable. The second assumption that I thought of, and again, you might be able to think of other ones and add them to your investigation, but my one is we assume that all chickens would be counted the same, even though some may have been mixed breed and or looked different. So we didn't actually say how they were counted. So if some chickens were mixed breed or looked different, this may change how they are counted. The question doesn't state whether a chicken needs to be completely black or completely not black in order to be counted as black. So some people may count some chickens as black when they're only partly black, and other people might not count those chickens as black. So you're measuring different things depending on who's counting. And how that would affect the results is it would make the results unreliable, as people may be counting chicken colours in different ways. If chickens that should be counted as black are counted as not black, it would decrease our probability of a chicken being counted as black and increase the number of chickens counted before 2 black chickens are found. So I'm looking at the effect on the probability and the number of chickens checked. So those are the two things that I concluded. So I'm investigating how that would change my conclusion. If chickens that should be counted as not black are counted as black, this would increase the probability of a chicken being counted as black and decrease the number of chickens counted before 2 black chickens are found. So you're measuring different things at different times, and so it would make your results unreliable. So my recommendation is, so how you could make this more accurate is having strict rules for when a chicken is counted as black or not, such as only counting the chickens that are completely black. This would prevent variation in how the chicken colours are recorded and would give me a more valid and reliable result in my simulation. So that's what you can do to improve the investigation. Now, let's talk about grades. Ideally, I'd like you to investigate as deeply as you can into this, because that's where you get the most learning. But I know some of you are interested in how you will get what grades, so I'll talk about that now. In order to pass, in order to get achieved, you need to write the tool properly. So write this part properly depending on your investigation question, so it will change depending on the question you've got. You need to write the trial properly as well. You need to have the recording done properly, and you need to have the probability done properly, which is this part and this part. And you also need to say this part here. That's to pass. In order to get merit, you need to do all of that, and then you need to work out the average number of chickens checked to get 2 or more black chickens. So, and which is these 2 parts here. So you need to do the full tool, trial, record, and conclusion. So that means you need to have this as well. That's for achieved as well. For achieved, you need to do up to this part here. For merit, you also need to have this column. And remember, you always need your key, whether you want achieved or merit. For merit, you also need to have one good assumption. For excellence, you need to do all of that, and you need to have 2 good assumptions. You can do 3 so that you have a backup. Thanks for watching. Good luck. Let your teachers know if you have any questions. They'll be happy to help. Thanks for watching.